So last time we have implemented in order traversal in a non-recursive way. That means we have used stack instead of recursion. So in order traversal usually we do using recursive method. This is the recursive way to do in order traversal. You can see here a node is provided, node pointer, and this is the base case. This is the base case. In order, that means this is something, the same function is called for left side, and then the node is printed, and then in order function again is called node get right. That means right side tree. So this in order will call in order function again and again until node is equal to null pointer. So let's implement it. So here void in order is the name of the function, and we put here const, and here binary node pointer is provided as a input argument. So it is something in order traversal. I just put in order traversal, in order traversal. So so let's implement here. So it will be a template, and we need to provide class name with resolution operator, and then here body. So if node not equal to null pointer, then we will have here set of statements. So then we can traverse to the left side. That means we first in order traversal we print left subtree first, and then node, and then right subtree. So let's see, if node get left is not equal to null ptr, that we are looking for the left side, then this in order function, in order is called, in order and node. That means we are moving to the left side, and we get left, right? So if this node, left node, is not null pointer, then traverse in order traverse. That means call again the same, and then if I copy this one and here, and I put here right, and then get right, that means this is left and this is right, and here between them I and I'm calling in order again and again, but between them I will print node cout and dereference now node, and just we can have here some comma. So this is a recursive function, very easy, few lines, so very simple function. Just going to left side until we have nothing, and then print, and then go to right side. So to call this in order function we need one helping function. So let's see one helping function, and this function having the same name but without any argument. So it's again it is something. So these are overloaded functions. You can make this function with some other name, but in the book the name of these two functions are same, so overloaded function, no problem at all. So let's implement this function. So here you can see we need to make it again template, and here it should be some body, and this is resolution operator like this one. So let's see, this function will call this recursive function, right? So it is common, we will have detailed discussion in the class about the recursion. So let me write here, just print something, some introductory sentences. So we can have here in order traversal using recursive method, right? So recursive method, and we can just move to the next line, and we can have here a bracket, and we can have a bracket at the end, closing brace, and here we can call just this function in order. This function need a pointer to node, we will provide root node. So it is very simple. So most of the function you will have having very similar nature, get count and then node as input as parameter. So these overloaded functions are used in the same way, get count, get height, get leaf count, and in order you can see these are overloaded methods. So we have done, so let's test it. So we can we can have here tree dot in order, so we can call this one, and then again we can have new line. So let's again we have some problem. uh, so again, so let's build this solution. More problem. If I forgot too many, so okay, this time there is not any error, so we can have, so you can see here, so same output. So in order traversal using stack and in order traversal using a recursive method. So uh, we have obtained the same results. So another way is this is a level order with queue. Let's see what is a level order. So detailed discussion will be done in the class, but here you can see, as you know, the root node always uh, at level 0. It has level 0 and then next level 1, 2, level 0, 1, 2, 3, 4. So level order traversal mean we start from the 0 order and then first print all elements on the 0 order, then all elements on the 1 order, and then other levels and other levels. So this is something the level order traversal, and it is not a recursive method, recursive approach. So we need a queue data structure. So let's implement it and I will explain it in the class. Let's have here function name is level order um, traversal, level order, just level order, its name is level order. You can see here void level order traversing, and we can put here const. So level order traversal. So let's implement this function. Its body maybe we can put here. So we have body here, and we need class name with resolution operator, and because it is a template, so we need to put here this one, and here we can write. So for this method we need a queue data structure. So just like a stack template from the STL, we can include queue. Sorry, here we need to have angle bracket. So it is a queue template from STL. So um, built-in library. This is something built-in queue data structure. So we need to we need this one here. We will use. So Level order, it is again not complex. So few sentences: see out level order traversal using queue, and then we can move to new line, and also we can put some opening brace, and at the end we will have a closing brace. So then between these two braces we can print um, so uh, first we need to check if not is empty. So is empty function we need to write. So first we need to write uh, this uh, this function is empty. So let's say we can write very simple function is empty. It is a boolean function, is empty, and we can have this function as a const function, and it returns 1, returns true if tree is empty. So we can write its body here. It is also a template, and its body is here, and this one is also here. So then if so return root equal to null ptr. So simple, if root is null ptr null pointer, then the tree is empty. So if not is empty, then we can traverse, otherwise there is no need to go through the. So we will uh, have a queue, right? Data structure queue of type binary node of type t and pointer. So we have a queue, and queue dot queue dot push, we can push root node, and then we may have a while loop while queue is not empty, while queue call empty function, right? So this empty and push, these are built-in functions of These are built-in function in class Q. While not empty, then we can create here binary node T of type T pointer node equal to we um, we will create this one and uh, Q dot front. That means we will get node from the front, and then we will remove this one, this node from the front, and then if node not equal to null ptr, then print it std cout and dereference node, and then you can also print a comma. So then you can push, that mean add elements. So node get left side child, left child, and also we need to push right side child. So push node get right. So this is something the so every time we can put this node outside. We can have here equal to new, this one, and then just we can use this yeah, we can use this one. So that's okay, no problem. So, what we are doing in the beginning, I will explain in we will have some demo in the class. So we are doing in the beginning, we just put the root in the queue, and while queue is not empty, so in the beginning there is one node, because if it is not empty, then at least there should be one node. So then we will take out this node, and its and print it, and its children are um, children are NQ. Actually this push is like NQ, that the left and right children are pushed onto the queue. So let's see in tree dot level order, and then we can also move to the next line. So let's build solution. So no error. So let's so you can see here, so level order, let's see level order, um, 14 and then 415, 415 and then 3918, 3918 and then 7 16 and 20, and at the end 5 and 17. So this is something level order traversing, and we have implemented it. So in the same way, now I hope that you can implement uh, all other all other functions. So post order, and pre-order, and get leaf count, get height, and get count. So the code is given in the book also, and I am using almost the same code that is given in the book, but I just change the style, and I am using just some more C++ um facilities. So please implement rest of the binary tree.